that's what I'm doing for you. And just to see the example, so this is the, I mean, you know, dynamic programming, so essentially you have really all there is for you, all it is is a Bellman step function. It takes in the state, gives you the next state, and when you have some convergence, acceptable convergence, you say, okay, that's the result. So that's really dynamic programming. That's the dynamic problem. I did it for discrete state, and also because the state was discrete, I was able to parallelize it. So in case when for instance, if this state vector that you're working in, if it's too big, and when you're doing the optimization function on that state space, you can also parallelize that, so you can get the speed up also from there. And this is just an illustration of what I mentioned, the structural estimation case, where you have this expensive function that you need to invoke in the optimization procedure. And somehow, I mean, that can be parallelized, but needs to be linked back into this optimization application. So these are the things that we have worked on. Like I said, I do more the high performance resource adaptation, linking of the components part. Victor is the one who looks at the model, understands. Actually reads the paper. I don't always read the paper. I don't always understand what I read. So he reads the paper, splits it into pieces, makes it work properly, hands it back to me and says, you need to combine them this way and run them. So that's how we do this. This is the way to do this kind of work. We have had significant ongoing effort. I mean, you've seen how much stuff we have done. We just started a year and a half ago, approximately. And we built up a lot of experience with this work. It's a huge investment. Townsend mainly, I mean, he's paid Victor and others from the CI, and from the CI just had to balance out what Townsend has invested. So there's a huge investment in actually doing this kind of work and pushing out the research so that it's more usable, reusable, useful, anything you want to come up with. We're looking for common research topics. Hopefully, if you came here, you have something computational, or you have some ideas, or you can just tell us whatever you think about everything. We're willing to work with people who have these kinds of problems, these kinds of computational constraints. It's our time is limited, but I mean, we will work with people who have this kind of problems, or at least will just talk, or anything, do some joint research, anything that seems useful on both sides. So just to check on resources, I mean, just to see what we've worked on, read all his papers, thousands of papers, if you want to actually see the exact details of the problem that we worked on. We have a lot of software expertise, tools that we have used to put together all these nice and shiny images that we saw. The main resource is this, and where we kind of write what we do. So on the wiki we have actual details on how we do all this computationally intensive work. I mean, those are details to the problem. If you need to learn from them, definitely you'll find them when we just solve a big problem, or we run into some thing that we solve, we put it there so we don't forget it in the next situation. So that's really, and this is just a part with the dynamic programming, which is in case you want to, you need to solve big dynamic problems. So that's pretty much it. So if you have questions, ask me. If not, a lot of questions.
I know that. I'm going to. So let's say you had, in the context of like your ideas about like modularizing economic models for sort of so that the models can evolve as well. So say you had in your fantasy world some sort of highly parallelized, like dynamic model, forward-looking dynamic model that was really awesome and sophisticated, and you wanted to get some economist to come along and improve like some module of it. I mean, it seems to me that like the parallelization process usually requires a lot of like very specific work. Like when you describe it, like you have to do all of this specific work to sort of
But that's going to be internal to the rest of the model. So let's say when some economist comes by and says, my research is in relating, I don't know, education to income or to occupation. I'll tell him, well, you know, I have a big model which has a very simple connection between those two, but if you have a more complex research, fine, I'm just going to replace my link between education and income with your research, and we're going to work with what you have, with the example that you have, with the model, and the case that you have, such that when we integrate his research into the rest, it still works out and produces meaningful results. So essentially, all they have to keep in mind is I will connect my model, my work to somebody else's work, and I should be nice to them because we both are getting something from connecting these models.
Yeah.
So just when the design process is happening, when the model design implementation happens, you should keep in mind that there will be possibility that somebody will have to use my model in a setting, in a parallel setting, where it will want to use my model together with other models, and we should keep in mind that there's a need for a connection between what I do and something else. Essentially, that's the main idea. I don't know if I answered the question. I forgot the question.
Well, I mean, you think you can actually persuade, I mean, we've talked about this before, but you think you can actually persuade economists to do things in the modules that you tell them to do them in?
No, I'm not telling them to do anything with any modules. I'm just telling them, look, you could hook up your research to this thing. Do you want to hook it up or not? Do you see any use in hooking it up to this or not? So essentially what we do for Townsend, I mean, all these platforms, when we put together a huge database, Neil does 5 gigabytes of data from several surveys, 4 or 5 surveys now, that you can automatically make use of either in the model, in the case that I showed you, or in the future with other models. I mean, that's connecting data to models, data to research. So that's what I'm hoping, that we can incrementally improve on such a system that makes use of the economic research. I mean, that's what I want to do, make use of what these marketers have come up with and see a benefit from it. So I'm really interested if there is a benefit, because I need a motivation, otherwise I would just, I don't know, go to Wall Street a bit really, something else. And then I'll start actually thinking what needs to be built and how it should be built, and such that everybody benefits from it.